Hello everyone. This is Indhumathy, working as assistant professor in the Department of Chemistry in St. Josephs College of Arts and Science for Women Household. So today we are going to see about the manufacture of cement. First, introduction to cement. So cement is a binding material which is used in construction. It sets and hardens after mixing with water. It binds sand and aggregates together. Generally, it is used most commonly. It is used in used cement is OPC, that is ordinary Portland cement. So it is the essential material for buildings, bridges, dams, and roads. Then the history of cement. So ancient Romans used volcanic ash pozzolana. So that is modern cement. Nowadays modern cement was used, which was developed in 1824 by Joseph Asprin, which is named as Portland cement due to the resemblance of Portland's stone. So industrial production began in 19th century. Now one of the most widely used construction materials. So the raw materials for cement. So first is, raw material is limestone, that is calcium carbonate. It is the source of calcium. Then clay. So it provides the silica, alumina, and iron. Then gypsum. It controls setting time. Correct proportion ensures the quality of cement. Raw materials are chemically analyzed before they can use. Chemical composition of cement: lime CaO 60 to 65 percentage, silica 17 to 25 percentage, alumina 3 to 8 percentage, iron oxide 0.5 to 6 percentage, and magnesium oxide and sulfur trioxide, but that is minor components. So manufacturing process overview. So first two types of process will be there in the manufacture of cement. That is wet process and then dry process. So dry process is widely used today. So main steps involved in this dry process means crushing, then mixing, then heating, then grinding, and then packing. So it involves chemical reactions at high temperature. So it produces clinker as intermediate product. Then crushing and grinding. So limestone and clay are crushed into a small pieces so that materials are ground into a fine powder so that it achieves uniform particle size. It improves efficiency of the chemical reactions. It is stored in silos for further processing. Then mixing and blending. So raw materials are proportioned accurately. It mixed to form raw meal so that homogenization ensures uniform composition. It prevents variation in cement quality. Quality control tests will be conducted. Then heating in rotary kiln. So raw meal fed into rotary kiln. Then temperature is raised to about 1400 to 1500 degrees Celsius. So chemical reactions will be occur on that region. Then the formation of clinker nodules. The fuel used for that is coal, oil, or natural gas. Then clinker formation. So lime reacts with silica, alumina, and iron. It forms the compound like C3S, C2S, C3A, and C2AF. And then clinker is dark gray nodular material. It is rapid cooling, preserves desired properties so that it can be stored before then final grinding and addition of gypsum. So clinker is finely ground in a ball mill. So 3 to 5 percentage of gypsum is added. The gypsum's control setting time. It produces fine cement powder. Then it is packed in bags for distribution. So types of cement. So there are five types of cement. That is ordinary Portland cement, that is known as OPC generally. Then Portland pozzolana cement, that is PPC. Then rapid hardening cement, and then sulfate resistant cement, then white cement and special cements. Then physical properties of cement. So the cement fineness, setting time, soundness, strength, and specific gravity. Then fineness of cement. So fineness includes particle size so that it can measured by sieve test or Blaine's air permeability test. The finer cement gives more strength. It increases rate of hydration. Excess fineness may cause cracking. Then setting time. So initial setting time minimum 30 minutes, maximum 10 hours. Final setting time will be 10 hours, measured using YCAT apparatus. So it is important for construction workability. It is controlled by gypsum content. And then soundness. So the soundness property means the ability to retain the volume after setting. So excess lime causes expansion, which can be tested by leach clear apparatus. Unsound cement causes cracks. It ensures durability of structure. Then the strength of cement. It is measured by compressive strength test. So that can be tested after 3, 7 and 28 days. So higher strength and ensures durability. So depends upon composition and curing, which is expressed in MPa. Heat of hydration. So in this process the heat can be released during chemical reaction with water. So it is important in mass concrete works, so that excess heat may cause cracks. So low heat cement used in dams, so it can controlled by composition. Then chemical properties of cement. So lime saturation factor, alkali content, loss on ignition, insoluble residue. It affects durability and strength. Then advantages of cement. So high compressive strength, durable and long lasting, and then easily available, versatile in construction, then economical material. Thank you.